What pollutants or contaminants are present in the sewage? And what do we need to remove? Why? And to what extent? In this lecture, we will focus on the major pollutants in the domestic sewage. The largest fraction of contaminants in domestic sewage consists of organic pollutants. Since water is a polar compound, it's an ideal solvent for many organic pollutants that are associated to our food chain, such as sugars, proteins, ionized compounds, alcohol, etc. Can you think of an organic compound that hardly dissolves in water? Maybe fats. The lower the polarity of a compound, the lower the solubility of that compound, but we still find them back in our sewage and thus in our treatment system. In addition to dissolved compounds, the used water carries a lot of suspended matter. These suspended solids can be of organic nature, such as food left over thrown in the kitchen, or fecal matter from our toilets, but also they can be inorganic, such as clay and sand particles, or when flows are high, even small stones. Water is mostly used for transport of reactants to and transport of contaminants from the site of industrial and/or agricultural production or household appliances. The carrying capacity of water is determined by a number of factors. Some of them are related to the physical-chemical nature of the pollutant, such as the polarity of the compound, the maximum solubility, the degree of ionization, etc. Others depend on the type and extent of the sewage system, local weather conditions, and thus flow velocities in the conveyance pipes. Now think for yourself and imagine at least 10 compounds that come back to your mind that you certainly will find in the sewage. Kitchen waste, fecal matter, urine, soaps, detergents, proteins, fats, sugars, fibers, urea, ammonium, phosphates, medicine rest, pathogenic bacteria, toilet paper, chemicals that don't belong there, such as paint, vegetable oil, sand, leaves, tree dust, clay, stones, mice, rats, everything. I guess that matches more or less with your imagination, right? Now the question, why should we remove these compounds? Why are they harmful? Discharge of organic compounds leads to surface water pollution, possibly resulting in oxygen depletion. The actual impact on the dissolved oxygen concentration depends on the composition and concentration of the specific compounds, as will be discussed during the coming lectures. Since the exact nature of the organic compounds is not known, organic matter is determined in analytical tests. Based on the type of test, the organic matter content is expressed in gram chemical oxygen demand, or COD, or gram biochemical oxygen demand, or BOD. The fundamental background of these tests will be discussed in another lecture. In addition to carbon pollution, the sewage is full of nutrients, nitrogen and phosphorus. The presence of these fertilizers in surface water leads to eutrophication, resulting in high algae growth or algae bloom. By the massive growth of algae, other species will hardly have the chance to flourish in these waters, thus leading to a loss in species diversity. Moreover, after starvation, the dead biomass will also lead to oxygen depletion in the receiving surface waters. Therefore, effluent restriction of sewage treatment plants generally include both organic matter and the nutrients. The natural carbon, nitrogen and phosphorus cycle, as well as the imbalances in these cycles, will be explained in much more detail when we discuss the biological processes in sewage treatment plants. Back to the wastewater. Wastewater is composed of almost 100% water. The polluting mass is only a very small fraction of the total mass. Of the polluting mass, about 70% is of organic nature and about 30% is inorganic. The organic fraction consists of 65% proteins, about 25% sugars and about 10% fats. Local conditions may differ distinctly from these average values. The inorganic fraction consists of sand and grit, salts and metals. Part of the pollutants are present in a soluble form, whereas a large part is suspended. How do we quantify the solids that are present in the sewage? Suspended solids quantification is based on their settleability, their size and their organic or inorganic nature. Organic solids are also called volatile solids or VS, referring to the way of quantification. Organics are separated from the inorganics by burning the solids or volatilization in a muffle oven of 550 degrees Celsius. Non-volatile fraction or ashes are called the fixed solids or FS. A rough classification of the solids present in the sewage is given in this slide. Now let's start with a sewage sample and first check what part of the solids is settleable. The settleability of the solids is an important characteristic when we apply downstream solid separation. Under standardized conditions, the amount of settleable solids is determined by using an Imhoff cone. Alternatively, if we evaporate all the water of the original sample, the residue is called total solids or TS. By means of a filter with a certain mesh size, we may differentiate between the filterable dissolved solids, like ions or sugars, and the suspended solids. If we burn the solids fraction in the muffle oven of 550 degrees Celsius, we obtain the volatile suspended solids or VSS and the ashes or fixed suspended solids or FSS. The oven-treated filterable fraction will give us the volatile filterable solids and the fixed filterable solids. Now, by summing the appropriate fractions, as shown in this slide, we can close the mass balance and we come to the total solids again, which must be equal to the initial amount after evaporating all the water. A practical example is given in this slide. Just have a close look and stop this video and do these simple calculations by yourself. The characterization of sewage is important to understand what impact the discharge of untreated sewage will have on the environment. Alternatively, sewage characterization is performed in order to be able to dimension a sewage treatment plant. The sewage characteristics are firstly dependent on the type of collection system or sewage system that we apply. Flow rates and expected fluctuations herein depend on the extent of the sewerage and whether rainwater is collected by the same system, as we discussed in the previous lecture. The flow and pollutant concentration are then used to design the treatment plant. After treatment, the effluent is again characterized in order to check whether discharge or reuse standards are met. The present slide lists the average concentration of key pollutants in sewage in the Netherlands. In addition to BOD, COD and suspended solids, also concentration of nutrients, nitrogen and phosphorus are given. Both nutrients can be present as inorganic compounds such as ammonium, nitrite, nitrate, orthophosphate, or they are bound to organic matter. Particularly the presence of reduced nitrogen compounds need to be carefully assessed at the STP in both the influent and the effluent. Since reduced nitrogen needs to be oxidized in the reactor before discharge to the environment. The total amount of reduced nitrogen is measured by Kähler method, a destructive technique in which all reduced N is made free from organic matter. The released organic N, as well as the ammonium, is measured in this test. What does it mean that the concentration of total N and Kähler N are about the same in the sewage? For phosphorus, generally total P is measured, which includes both the phosphorus bound to the biomass and the free reactive orthophosphate. Our sewage can be characterized as dilute, having the following average concentrations: BOD of 180 mg per liter, COD 470, Kähler nitrogen 40, total N 40, total P 6 to 7, and suspended solids 150 to 200. The large presence of suspended solids in the influent indicates the rather complex nature of organic pollutants entering an STP. Next to the biochemical compounds, the influent is contaminated with huge numbers of human pathogens. The average pathogen concentration, measured as the number of indicator organisms, E. coli, is about 10 to the 7, 10 to the 8 per 100 ml. In addition to E. coli, the effluent contains high numbers of other bacteria, viruses, and protozoa like Giardia and Cryptosporidium. During activated sludge treatment, no more than 1 to 2 log units of pathogenic organisms will be removed. Notably, pathogens are not removed in our sewage treatment plants. Only in those cases where the effluent is discharged to surface water where public bathing is allowed, pathogens need to be removed to less than 1 per mil. Pollutant concentrations in sewage may largely differ within a country and between different countries. Check out the very different concentrations for COD, BOD, total solids, nitrogen and phosphorus. You can imagine that these large differences will impact the type and design of the required treatment plant. Also, climate conditions, such as ambient temperature, will have its impact on system layout and process design. And what are the criteria that should be reached in the effluent of the STP? Since the installment of the Dutch Water Service Act in the 70s, the oxygen-requiring pollutants and suspended solids were restricted for discharge. Effluent restrictions for BOD was 20 mg per liter, for killed nitrogen 20 mg per liter, and for suspended solids 30 mg per liter. In the 19th of the past century, restrictions for nutrients were adopted, resultant from international agreements as outlined in the North Sea Treaty. Effluent restriction for phosphorus was set to 1 to 2 mg P per liter and nitrogen to 10 to 15 mg N per liter, depending on the size of the treatment plant. As a result of the stringent nutrient criteria, the effluent BOD concentrations dropped considerably. At present, the effluent nutrient concentrations are revisited as outlined in the European Framework Directive, particularly for large STPs and those STPs located in ecological sensitive zones. In various STPs in the Netherlands, effluent nitrogen and phosphorus concentrations already need to comply to lower standards, as low as 2.2 mg N per liter and 0.15 mg P per liter. These are being discussed, which will put a very high pressure on all operational STPs. For practical reasons, 5 mg N per liter and 0.3 mg P per liter are the more stringent criteria for nutrients which are now being adopted in the Netherlands. Other health and environmental concerns within our current sanitation system include the increasing presence of priority pollutants, medicine rest, endocrine disruptors in the effluent. Also, residual chlorine in the effluent when applied, or volatile compounds leaving the treatment plant with aeration, are compounds of concern, but yet they are not in the effluent restrictive guidelines. As discussed in our previous lecture, heavy rainfall may result in combined sewer overflows or CSOs. Since more periods of heavy rainfall are expected owing to climate change, uncontrolled discharge of dilute, non-treated sewage is a growing concern. Despite the growing concern, appropriate monitoring techniques for the mentioned discharges are yet not implemented, and so far it is yet not known how these compounds will impact our drinking water resources in the future. Let's check for the fundamental aspects of the COD and BOD measurements in our next lecture. Thanks for watching.